we just solved exponential equations by rewriting each side with the same base. But what happens if you can't do that? In other words, it's impossible to write 4 and 15 with some integer base. And so we're going to use a different tool, and we're going to use one of the properties of logarithms that we learned in a prior lesson here, and that is if you have the log base b of m to the r, that's equal to r times the log base b of m. And so the logarithm becomes a tool to help us isolate an exponent when you have a variable up in the exponent. Now generally we use either natural logs or common logs, but I will show you that you could actually use any base that you wanted to. So let's start off with this problem right here, example 2a. I've got 4 to the x equals 15, and so I have to isolate the exponential expression, which is done already in this problem. And so I'm going to take the natural log of 4 to the x, and I'm going to take the natural log of 15. So I'm taking the natural log of each side. Now using the power rule, I can bring that exponent down as a factor. So I have x times the natural log of 4 equals the natural log of 15. I'm going to divide each side by the natural log of 4. Remember, the natural log of 4 is just a number. It is some value, irrational, but it is the exponent that you put on e that results in 4. And now this is considered my exact answer, and sometimes we like to leave our answers exact. Often we need to approximate our answers, so let's use a calculator to do this. So we're going to take the natural log of 15, close the parentheses, divide that by the natural log of 4, and close the parentheses, hit enter, and let's round our answer to the nearest hundredth. So this is approximately equal to 1.95. Approximately equal to 1.95. Now I would like to show you that there is an alternate way of doing this particular problem. So if I started off with 4 to the x equals 15, I could take the log base 4 of each side. So if I took the log base 4 of 4 to the x and the log base 4 of 15, well, using one of the inverse properties, right, when the base and the argument space are the same, the log base 4 of 4 to the x, that's actually just equal to x. So x equals the log base 4 of 15. And now here, you don't, we talked about this before, you don't have a calculator button with a log base 4, but you can use the change of base formula, which says that the log base 4 of 15 is the natural log of 15 divided by the natural log of 4, which we just got right here. So there is an alternate way to do that same problem. Generally, it seems to be a few more steps here. I either use a natural log or I use a common log to solve these. So let's move on and try part B. Alright, so we have 10 to the x equals 120,000. This time, since the base is 10, instead of using natural log, which again, you can use natural log every time if you want, but I'm going to use just log. I'm going to take the log of 10 to the x equals the log of 120,000. The log of 10 to the x equals just plain old x, because remember the base is 10. This equals the log of 120,000. I'm going to evaluate. So this is again your exact answer, but we also would like to have an approximate answer, and so we'll use our calculator to help us get that approximate answer. So now there is an log button, right? So there's the log, that's implied base 10, 120,000. Okay, close the parentheses, hit enter, and if I round that to the nearest hundredth, I'm going to get 5.08. So this is approximately equal to 5.08. So I'd also like to show you that, again, because your calculator has an LOG button and it also has a natural log button, let's solve this same problem only using the natural log. So let's take the natural log of both sides. This brings the x down. Okay, so I get x times the natural log of 10 equals the natural log of 120,000. Divide each side by the natural log of 10. And so this cancels. X is equal to, this is another exact value, the natural log of 120 divided by the natural log of 10. And open up my calculator again. And so this, it does add an extra step to use a natural log when your base is 10. But let's just want to show you that you will get the same answer. I'm going to take the natural log of 120,000, close that, divide that by the natural log of 10, hit enter, and you can see we get the same exact value. I'd like to do one more example with you before you try a few problems on your own. And so this part C, we're going to first isolate the exponential expression, which is the 40e to the 0.6x. So I'm going to add 3 to each side. I'm going to get 40e to the 0.6x is equal to 240, adding 3 to each side. I want to divide each side by 40. I really just want to isolate the e to the 0.6x. So if I divide both sides by 40, I get e to the 0.6x is equal to 6. In this case, I'm going to take the natural log of each side. The natural log of e to the 0.6x is equal to the natural log of 6. Now the natural log of e to anything is just that exponent, remember, because the base here is really an e. So this leads us to 0.6x is equal to the natural log of 6. I'm going to divide each side by 0.6. So x would equal the natural log of 6 divided by 0.6, or let's put this in our calculator to get an approximate answer. So we'd have natural log of 6, close the parentheses, divided by 0.6, hit enter, and again we'll round this to the nearest hundredth, so we get approximately 2.99. Before you start the problems, just remember that in general you can use any base that you want when you're taking the log of both sides. It's more common to use a natural log or a common log, but remember when we did the 4 to the x problem, we used the log base 4 of x and we still got the same answer. It required a little bit more work. Okay, so pause the video. Try these problems using what you think is the most efficient way. Okay, let's solve 5 to the x equals 134. So I'm going to take the natural log of both sides, natural log of 134, use the power rule, x times the natural log of 5 equals the natural log of 134. Divide both sides by the natural log of 5. And then we'll approximate this in our calculator. Alright, you want to take the natural log, so ln of 134, close the parentheses, divided by the natural log of 5, and hit enter. And we'll just round to the nearest hundred, so it would be approximately 3.04. Alright, Alright, let's solve 10 to the x equals 8,000. We're going to use the log, which is implied base 10, so we're going to take the log of each side. Remember that there is a 10 there, it's just implied. The log base 10 of 10 to the x is just x. So the exact answer is the log of 8,000, and we'll find the approximate answer by using our calculator. So we'll take the log of 8,000 and if we round to the nearest hundredth, the answer is approximately 3.90. Alright, and the last one, 7e to the 2x minus 5 equals 58. We want to isolate the exponential expression first. We want to get that e to the 2x by itself. So adding 5 to both sides will give us 7e to the 2x equals 63. Dividing each side by 7 will give us 9. We're going to take the natural log of each side. Natural log of e to some power is that power. Remember, the base here is e, it's implied. So we get 2x is equal to the natural log of 9 divided by 2. So the exact answer is the natural log of 9 over 2. The approximate answer we will get by plugging into our calculator. We'll take the natural log of 9 divided by 2. We'll take the natural log of 9, close parentheses, divided by 2, hit enter. And the answer, if we round to the nearest hundredth, is approximately 1.10.